Welcome to Mr. Carlson's lab, and welcome to the continuing Grand Receiver Restoration series here on this channel. If you're new to the series or new to the channel, what's going on is I'm restoring a whole bunch of these old communications receivers from way back when. Everyone is different. I'm restoring them all electrically so that they perform the way they performed when they rolled off the factory line way back when. And in the end, I'm going to line them all up here on the bench, and we're going to compare them one to another to see which one performs the best. So to give you an idea of what's in the lineup and what's going to be compared to what, this is an RCA CR-88, very close to the AR-88 and other variants. This is going to be compared to a Hammarland SP600, a Collins R390A, a Raquel RA17C12. You may be familiar with the RA117. They're both very close to each other, almost identical. And this is going to be compared to a BC348, one of those radios that was flying around in a warbird way back when. So all top-notch receivers. So that should be a lot of fun. If you haven't subscribed, you're definitely going to want to do that now if you want to stay current with this restoration series. And don't forget to tap the bell symbol and do all that stuff that YouTube wants you to do to get notified when I post a new video in this series. So what I'm going to do now is I'm going to start replacing the capacitors in the bottom side of the chassis here, and we're going to try this thing out and see if this thing comes to life with just that done. Again, we're working towards an entire restoration. We're going to make this thing perform the way it did when it rolled off the factory line. The first capacitor block that I'm going to replace is this one right here. So I'll remove this capacitor here, and I'm going to solder 3 brand new capacitors from these 3 points here to the chassis. 1/4-inch nut driver on the top side of the chassis here. Let's get this down into here. Get it down. It's pretty tight back in here. There it is. So I'm just holding the screw on the bottom side of the chassis with my finger, and I'm just undoing the nut from the top side here. All right. There's that one. And this one here. And then 1, 2, 3. And there's one extra wire that is on here. I see. I will most likely join this wire. Clip that up here, give myself a little bit of extra wire there. And this will allow me to pull this off on the side like so. Just like that. All right, so I'll just join this one up to here like this. And there'll be 3 capacitors that run from here to the chassis. That gets rid of this one little block. Now, I'll just zoom in on this here. Now normally I would, open something like this up, right? But what's inside these blocks isn't all that incredibly friendly, so I'll save that for a future episode when I open these up, and I'll show you what's inside these things. But for now, I want to get these things out of there, and we'll just end up using regular capacitors from here down to the chassis, which will work just fine. I'm going to replace this capacitor block with 3 of these new capacitors right here. Now, one of the things that modern capacitor manufacturers don't do is they don't mark the outside foil, just because nowadays these things are sitting on a ground plane on the circuit board. It's not that incredibly needed for circuit boards. When you're installing these things into older radios, it's very important to put these things in the correct way, and that's the reason that older capacitors always had a band end on them, and it said outside foil or ground end. Now, what that means is the lead that is closest to the band is attached to the outside foil in the capacitor. So it's like a shield over the entire capacitor right up to this end. So if I was to say this was the outside foil end here, if I was to tie this to ground, this would shield the capacitor right up to the lead. Now you'll notice the capacitor that I'm removing is completely shielded. right up to the lead. So I want to establish that again. This is very important to do when you're restoring these older radios. Well, since there really is no device on the market that does this, I designed a device and I released this whole thing with all the plans on Patreon. So this is one of the devices, just one of the things I've created up there. There's many different devices I've created like this one here. And I use that to actually test the old capacitors that come out to see how incredibly leaky they are. So I'll remove all the capacitors here and we'll just pull one out and test one for leakage. And I'll show you how bad these capacitors are. Many people think these things are fine to leave in circuit. Well, I'll show you different here quite shortly. All right, so I want to locate the outside foil end on this capacitor. So what I'm doing is I'm looking for the least amount of LEDs lit here with the corresponding LED down here. This box is going to electrically flip the capacitor back and forth while I hold on to the capacitor. I'm acting as the noise injector. So just the noise in the room and just everything is, everything that's in your switch mode power supplies and AC and everything is, I'm acting as this big antenna. So I'm going to pinch my fingers on here while this is in the clips, and you'll see this box will detect that noise, right? So what I'll do is I'll clip this onto these leads right now, like so, okay? And what I'm going to do is hold onto the capacitor right in the center, just like this. I'm going to turn this box on, get this out of the way so you can see the lights. And we can very easily see the outside foil. Look at how much noise I'm putting in there. So I'm looking for the least amount of LEDs lit. I can set the sensitivity up with this here, so I can turn it down or I can turn it up, depending on the capacitor that's being tested. So right now, the least amount of LEDs lit right now with this corresponding LED is the outside foil. Least and corresponding LED. So I do this to every capacitor that I install, along with other tests as well, to make sure that every capacitor is functioning properly. Because yes, you can buy brand new capacitors and they don't work properly. I've had very good luck with these though. I don't think I've had even one that's bad. So now that I've detected this, see if I let go of it, and let's move these leads out of the way, you'll see that it's not detecting anything. You can just see the switch back and forth. Whereas if I grab onto it, that's me putting noise in there. That's just surrounding noise from the room. So now that I know that this side here is the outside foil, that is the side that will go towards ground. So what I do is I mark this side with a pen. So I just put a little dot on the side. Right, so I'll just put this down for a second. Grab my pen, and what I do is I just put a little dot here, just like so. See that there? Little dot, and that marks the outside foil. So this is the side that will go to the chassis. So that will go down here like so. Now don't be confused by the writing, because these things go down the line any old way. So these things will run down the line this way or this way. So just because the writing is going this way right here doesn't mean that all the capacitors will have an outside foil end on this end, right? They go down the production line any old way and they just print this on here. So some are on this side and some are on this side. You have to have a device to detect that. What I'm going to do is remove these three little stubs that I've left here so that I can clean this area up. Then I'm going to also want to check these resistors to see if these resistors are still in tolerance before I put the new capacitors in here. A lot of the times when these old capacitor blocks get leaky, what they do is they stress out the resistors and the values go high. It's pretty common. So I'll grab my soldering iron. Now, one little trick to make this solder a little bit easier to work with is to add a bit of solder to it. So what I do is I just add a little bit of solder to each one of these to remove solder. So you add to remove. So now, with a pair of pliers, put this on here like so. There's one. And this one here. 2. Of course, if you're following along, you're doing so at your own risk. Use the appropriate eye protection. You can see that they used the lead off that one capacitor or there to carry through down that line. So I'm going to leave that one on that binding post there and just trim that off. So what they've done is they've taken a long lead, wrapped it around here, and then ran it to the capacitor. All right, so I'll just leave that one on so that way I've got a nice connection there. So this one, this resistor right here is supposed to be 1.5 megohms. So that's brown, green, green. Okay, so let's see how close this is to value. Okay, so I'll attach this up here, put the ground end here. This end is open. Okay, I'll put that there. And let's take a look up over here. I'll just move the focus over here. Pardon the fuzz for a moment there. So we're dealing with about 1.8 and it's coming down, no, about 1.8 megohms. So it's supposed to be 1.5. So that one's getting pretty high up there. All right, so let's move this over just a touch, like so. Just adjust the camera here so it's going to do this automatically for me. All right, so now, that one should probably get changed. Let's go back down here again. All right, so this one here is way off. Let's move over to the next one. This should be 100 k ohms. It's brown, black, yellow. See how close that one is. Move back up. And move this down here. 115K for a resistor like that. Yeah, the value is not too bad, but it's still a ways out. So the next one over is supposed to be 270K. So let's see what this one measures. So 270K is red, purple, yellow. Wow, these are all way off. So that's 533 k ohms. That's supposed to be 270. All right. So that tells me that all three of these resistors should go. So all three of these down here should get replaced. So in order to do that, I need to vacuum the remaining solder off of these, like so. And this one here, I'll do the same. If I can get this to melt, I might have to add some more solder again to remove solder. All right, and that's removing all the solder. So what I'll do now is I usually just go in here and give myself a little bit and then just clip these off and remove them like so, and then remove the remaining little bit on the bottom here. So again, we'll just test this for the fun of it now that, well, this one here is an open lead, so it really doesn't matter. Sometimes there's things on the backside attached to these, but this one here looks like there isn't on this particular board. I'll just take a quick look under there. No, there are no wiring connections under the board on this one here. So yeah, there's no point. So all three of these need to be replaced. I'll get these replaced and we'll install the capacitors. You'll notice in the upcoming clips of this video, this resistor here was installed incorrectly. I installed this resistor from this point here to this point here. It's supposed to be from this point here to this point here, like it is right now. Now, that really doesn't affect any of the tests going forward in this video. All that does is drop the audio level just a little bit. So it affects the plate voltage on the preamplifier tube, which is in the back here, which you can't see. So this is now corrected. I spotted this in processing at the end of the video, and I figured I'd just add a note in on YouTube, but nobody saw the note. And of course the comments start rolling in. So I figure since this is a documentary about this radio receiver, I should address this now. So take note, this is the correct way this resistor is supposed to be attached in circuit right here. Here's a little bit of information that isn't talked about a whole lot. So this is a modern, or a more modern, Allen Bradley style resistor. This is a 1/2 watt resistor right here. And this is the old 1/2 watt resistor right here. You'll see that the body style is much larger, much closer to this style right here, the one that I replaced over here. So replacing a resistor like this, which is a 1/2 watt resistor, with this type of a 1/2 watt resistor is absolutely fine. So a lot of people seem to think that these resistors here are 1 watt resistors, not to be confused with an actual Allen Bradley 1 watt resistor. So the Allen Bradley 1 watt resistor is just slightly bigger than this, and it has the squared off ends, where this old roundy style resistor is only rated at 1/2 watt. So two resistor body styles that can get rather confusing. 1 watt, 1/2 watt. The way to tell the difference is squared off edges to rounded edges. The next thing I'm going to do is clean out the chassis. WD-40 works pretty good for that, so I'll just spray a bit of WD-40 in this rag here, or this piece of paper towel I should say. And just wipe this out, clean this area out, like so. Just like so. All right, so now that that's done, what I'm going to do is size up where I'm going to put the capacitors. So this is the outside foil end, so I want this end towards the chassis. And what I'll do is I will just mount these in here like so. So I'll solder this end right here to the chassis. So I'll put all 3 of them in. Now, since I'm working in a confined area, I'm going to want to start with the first capacitor, which is closest into the chassis. So I'll solder that one first and I'll work my way out. So I want to rough up this area with just a little bit of either emery cloth or a piece of sandpaper. So I'm going to get a little bit of sandpaper and put 3 little spots here where I'm going to solder to. I'll show you what I do next. Now that I'm installing these, I want to make sure that I've got the right end towards the chassis. I want to make these about as even as possible. So just give that one loop. And I can size these things up by doing that. I believe that looks pretty even. So I want to have all 3 of these straight out. So what I want to do is press this end down towards the chassis now. Okay, and then I'll just clip this off down about there. Now, in order to keep this where I want it to stay, I'm going to put some solder on here. So that way, when I'm trying to solder the other end of the capacitor, it's not going to move all over the place. So I'll just put this here like so. I think my iron went into sleep mode there. Give me just 1 second here until this warms up. It should be warmed up now. There it is. It's coming to life. Let's put that there. Hold it there like so. And that looks like that's going to be pretty even. I'm thinking right about there. So lift that up. Hold the lead down against the chassis and pull the capacitor up, and then that way it kind of gives it a bit of spring tension against the chassis and it keeps this end down. So that looks to be about pretty even. So now what I'm going to do is I'm going to take just a touch of RA flux, put that on there like so. I'm going to take this very large soldering iron here. I'll move this out so you can see. Just touch the focus up. It's a very large soldering iron with a custom tip. I talk about this tip in my other videos. And I'll put this on the chassis like so. It instantly heats and you can solder to very large chassis areas no problem. That's the whole idea of this larger tip, is to be able to conduct enough heat to the chassis so that you can get a nice solder connection there. And that's the 3 new capacitors installed. What I do after I finish soldering them is I take a Q-tip with some lacquer thinner and I clean up around the solder area. So lacquer thinner melts the flux or the resin that's left over very, very quickly. And then I clean up the entire area around here, and it makes for a very, very clean connection. The next capacitor on the list to replace is this one right here. So this one is just over from the one that was just replaced. You'll notice the wires tie directly to the lugs on the capacitor. They don't go off to a board. So I can't just tie a capacitor when I remove this. I just can't tie a capacitor to the wires to the chassis because the wires are just floating. That would be a loose connection. So in order to replace these lugs, I need to install a terminal tie strip right here. Now, you'll notice that there's 3 points on here, but I only have 2 points on this tie strip. Well, if you look closely, you'll see that these 2 capacitors are bridged together. So this is making one capacitor. So I can replace these 2 with just one, and then I have this one capacitor here to the chassis as well. The capacitor is removed. And just like before, I clean the area out with usually WD-40 and just a cloth. Now what I want to do is I want to install this onto the chassis without drilling any holes. Again, I want minimal interference. I don't want to be adding more holes to the chassis. In fact, before I put this all back together, chances are I'll put the remaining screws from the old capacitors back in these holes just to fill it up. Now, this chassis has a couple of extra holes in it, probably from somebody over time adding something to this, but I don't want to add any more holes. So what I'm going to do is, just like with the capacitors, I'm going to rough this area up with a little bit of sandpaper, and I'm going to solder in the terminal tie strip. And that will hold this extremely solid. And again, I don't need to basically butcher up the chassis any worse than it already is, right? That keeps things nice and clean. So again, just, I find the area where I'm going to put the terminal tie strip. Probably just, center it or get it close. These 2 wires, the wiring is kind of, it's hard now, right? It's not as, doesn't move as easy as it used to. So the wires end up over here. So I'll probably mount it over here like so to get it as close so I don't have to move these wires around a whole lot because they are a little bit crusty now. So probably right about here is where I'm going to mount this. So then what I do is just mark the little area here, give it just a little bit of a rub just to clean off any oxidization on here, like so, right? And that tells me, okay, that's going to be there. So right over here, I can push this out of the way, just like that. That's all it needs, nothing more than that, because the chassis itself is plated and it solders to relatively easy. And just like so. So I'll give this just a bit of a rub. This is already nice and clean, but it doesn't hurt to add just a little bit more. Just make my life a little bit easier. So what I'm doing, I'm just cleaning this off, as you can see. That's all. So now, usually what I do is I create a puddle first, a little bit of a puddle, and then that way I get some solder onto the chassis and I pre-warm the chassis with that large iron. And then what I'll do is I'll put some flux on it and then add this on top and then push this down into the puddle and then even the puddle out on top. And that's the easiest way to do this, especially when you're working with, large chassis areas like this. It's a pretty thick piece of chassis here. What is that, about 14 gauge or something like that? So they didn't mess around when they put these things together. So what I'll do is I'll add some flux here and just get a puddle started. And then once that is started, I can do the other side once this is held down to the chassis. Then I can just add solder to the other side. So I'll show you what I'm doing here. Hopefully you can see this. I don't know if you can from that angle. Yeah, you can. Okay. All right. usually what I do is I just keep the iron on this for a few moments, and that helps heat the chassis, so it makes the second application when I want to push this into the puddle just a little bit easier. I usually rub the puddle around just a little bit. That helps with the wetting of the chassis. And I'll add just a little bit more here. And just let that sit for just a moment. Let it get nice and hot. I don't know if you can see that. It's a nice puddle there. And that's completely wetted into the chassis right now. So what I'll do is remove this. The chassis will remain hot for just a moment. And that'll allow me to push this down into the puddle. So this is tricky. I don't know if you're going to be able to see this because I have to come in from this side now. And I'm going to add some solder to the top of this. So that'll help conduct the heat down into the puddle below. And it's already sinking in. Not that great, but it is starting to go into that puddle. And I just have to sit here for a moment, even with this large soldering gun, to get this to go down. So some of you might be saying, well, it'd be much easier to drill a hole. Yeah, it would be. But then again, you know, you're dealing with that problem of adding more holes to the chassis. So it is coming down. This is a little bit time consuming. And there it is. It's settled onto the chassis quite nicely. So now what I'll do, hold it there for 1 second. See how nice that is? That's solid. That will not go anywhere. So now what I'll do is I'll go on to the other side and I'll solder this side because this is held in here completely solid now. So I'll go and add some flux and solder this side here, and then I'll clean everything up, and that'll be a nice solid connection. The terminal tie strip is now soldered to the chassis, and that is solid. So all I need to do now is put the wires into the tabs and put capacitors from the tabs to the chassis. The two capacitors are now installed. So you'll recall 2 of them were in parallel. So each capacitor was 0.05 microfarad. So since 2 0.05 microfarad capacitors are in parallel, that makes 0.1 microfarad, which is this one right here. And then we have one 0.05 microfarad capacitor remaining. So the nearest modern equivalent is 0.047, and that's what this capacitor is right here. Now the rest of the capacitors under here are pretty much the exact same procedure. So looking under here, I have this capacitor to replace, this one here, this one down here, and this one right here. So I'll install terminal tie strips for each one of these and just repeat exactly what I've done here. So when I've got all of that done, I'll be back. And quite some time later, all the bathtub style capacitors in the chassis down here have been replaced. The only capacitors that have not been replaced are the main filter capacitors at this point, and that will be done very, very shortly. But this should allow us to take a performance check and see any differences made just by replacing out these capacitors. We'll move one step to the next. I have a neat idea for replacing the filter capacitors, which will be very clean as well, and I'll share that in the upcoming video here in the restoration series of this radio receiver. So getting the terminal tie strips in portions of the chassis was a little bit difficult, especially with that, that large soldering tool over here, this thing. You see that over there? There it is. And it was a little bit difficult, especially down in here because of the shield. So I have 2 different style terminal tie strips. This one here has a center ground in it, and this one has an offset ground. And this one had to be mounted on an angle. The wiring that runs up to these capacitors because they're using the capacitor as a tie point as well, they are very short, so I had to mount the terminal tie strip very, very close over here. So this makes replacement of the capacitors much easier than working on these, but getting the terminal tie strip in is a little bit of a challenge. So a little bit time consuming putting this in, but it's worth it in the future. Again, you know, if anything needs to be replaced in the future, it's so quick and easy to replace any components now. So that's all of this stuff, lots of capacitors installed. So you know what we should do now is see if the radio receiver actually works, see if anything is different, and we'll take note compared to the very first video when we tried this thing out. We'll see if there's any differences. You'll recall in that video, some of the band portions were dead and it really wasn't all that incredibly sensitive. So we would turn the dial and it would, you know, it would just stop receiving, right? So I figure it's probably either to do with that tube or possibly the oscillator section or something like that, but we'll find that out as we go along. Oh, and we'll also check one of these capacitors. I'll share some of the misconceptions about these capacitors. Many techs seem to think that these things are absolutely fine to leave in circuit and they don't fail. I've heard this so many times and it's so far from the truth, it's not funny. Here's some capacitor knowledge that will give you the edge on other techs and engineers for that matter. So here is one of the capacitors that so many techs and repairmen seem to think are absolutely fine. And the reason that they think they're fine is because they test them on one of these devices over here. So I have this already set up. So I have this sitting at 400 volts. That's going to test this at its rated voltage. Okay, so if we look here, we can see 400 volts and it's 3 times 0.25 microfarad. So there's 3 0.25 microfarad capacitors that are all tied to the chassis here as a ground. All right. So we have 3 separate caps in here. So what I'll do is I will attach the leads of this. This is on discharge right now. And it definitely needs to be because there would be 400 volts on these leads right now if there wasn't. Okay. So now what happens is when I click this to leakage here, what's going to happen is this eye is going to close as it charges a capacitor, and then it's going to open if the leakage is supposedly minimal. So what I'll do is I'll lift the camera up here so I can zoom into the eye just a little bit easier here. All right, so now I'll click this onto leakage and watch what happens. That opened really fast, right? And if I click discharge, you'll see the eye close again for a second as it discharges the capacitor, and it'll open when the capacitor is discharged. See that, how quickly that was? So let's test it again. Wow, that's fast. So if you're a tech using one of these things, you'd be thinking, wow, that capacitor is really good. All right, so it is on discharge. So what I'll do is I'll move over to the next capacitor section and we'll test it. Okay. Test the center one. All right, let's do that again. Wow, that's fast. That's looking really good, isn't it? Move on to the last one here. All right, put that down here. The ground came off. That's not a good thing. All right, so here we go. Wow, looks good. So it's on discharge again. It's a very important thing to take note of. So you're thinking, wow, this capacitor is going to be absolutely fine in circuit. The eye opened really quick. This thing is going to be no problems whatsoever, right? So see this capacitor, right? So now what we're going to do is we're going to take a look at this with a much more sensitive device that has the ability to forecast. And we'll see what it does. Okay, so I'm going to stick the sense lead on here. Take a look. Okay, so we'll just test one of them. Now this is a really in-depth test, and it is a little bit time-consuming, but it's well worth it if you want to know what's really going on with one of these capacitors. All right, so I'll just zoom on into this tester here. So what I'm going to do is test this right now. So this is the discharge position. So that would be discharging the capacitor. And what I'm going to do is click this on to test. Okay, so right now this is counting down towards testing as okay. You can see this is actually red, the color of the so bright that it actually looks a little bit orange in the camera, but it's actually red like the LEDs up here. Okay. So now this is in the paper and poly and mica position, all right? So this is not the forecast setting. So now what's going to happen is we have one more range to go. This will pop back up to here and it'll go through one more entire range to really test this. Okay, so we're at about 1 gig ohm of resistance here at the rated voltage that this is testing the capacitor at. Okay. So right now what we're doing is we're looking for internal leakage resistance inside this capacitor. So this has the ability to go to a very sensitive test to give you the idea, or to give you an idea of if this is going to fail in the future or how incredibly leaky this actually is. So you'll see this start to count down here in just a moment. It's switched ranges. So again, the internal resistance is trying to charge this capacitor, and this device is just measuring that right now. So you'll see this count down. Again, the test itself with the box is time consuming. But if you want the answers, you got to spend the time. So you can see it's moving down, and it's moving down not too bad. So once it hits this LED, this will switch to green, saying that it's okay. Something like this test over here at 400 volts. This is testing this at a greatly reduced voltage. Okay, because we're looking for leakage resistance. Okay, so now here is where the important stuff comes in. You're going to see this go green here in a moment. Then what I'm going to do, that says the test is done and it's okay. But then I'm going to click this into forecast and watch what happens. We'll wait till it turns green. Okay, we're thinking, hey, it's just like the other tester. Now I'm going to click this into forecast. It'll give us an idea of what's going to happen in the future. Look what's happening. It's going the other way. That's because the internal leakage resistance of this capacitor here, the capacitor under test, it's discharging itself. So the capacitor is discharging itself through its own leakage resistance, and this is measuring that. Now, to give you an idea of the difference, okay, of a new capacitor, so what I'll do is I'll just put this on, discharges, just shut it off for a moment. So I'll grab the modern equivalent that's been installed, okay. And we'll take a look at the modern equivalent. So this is the modern equivalent right here. All right, so I'll just put this down like so. And we'll zoom back into this. So we'll start this out the same way again. So this is the modern equivalent, the brand new capacitor. And then we're going to forecast this one as well, and we're going to see if the internal leakage resistance drains itself. All right, so we'll see if the capacitor drains itself off like the other one. Now you'll find this interesting here. Watch how fast this moves down. Look at this, okay? So that's a new capacitor. So you already get the idea. Now it's in forecast. Notice it's staying green and it's not going back into the red. That's because this is a good capacitor. And this capacitor, even though that Heathkit tester says it's okay, is nowhere near okay. It's done. And that's why there's so many techs that get the idea that these things are still okay. No, it's not. So there you go. Hasn't come back up the scale yet. So I'll give this a little bit of leakage resistance just by touching this with my fingers. So there you go. Now watch, it's even counting down in the forecast position. It's still going down, where the other one was counting the other way. That's the benefit of having good test equipment. I'm all about the results, and I want accurate results. And when I design something, or if I am repairing something, I like to repair it and I want it to stay that way. So the work that I've done, I want to be as permanent as possible. And that's why I spend the time to build these devices. So this is another one of those devices that I've designed and released on Patreon. So all the plans and everything are up there as well. So anyways, we don't need to watch this anymore. So now, I'll give you one other example. So this is another capacitor that I've pulled out of the unit. Let me see, where is it? Here, okay. Okay, so this is another one that I pulled out of the RCA, CR-88, okay? So what I'll do now is I'll get this thing out of the way so I don't confuse leads and put 400 volts into my sensitive tester. Okay, so this is on discharge. This is also rated at 400 volts, this one here. Another bathtub style capacitor. Okay, 400 volts DC. Take a look at this. Closer, see if we can get that in there. So there you go. So that's 3 times 0.05 microfarad. All right. So now what we'll do is we'll test this one out. So this is a bathtub style capacitor. Okay. I'll zoom in on Heathkit over here. All right, let's see what this one does. That one is so incredibly bad, this one is even saying it's bad. That eye is not opening, so I'll click discharge. All right. All right, so you can see this one here is really, really bad. And of course, if I grab the sensitive tester here and hook this up, so I'll get these leads out of the way. And I will put this on here. Move down here. All right, so there it is. So this one is attached to this one now. All right, so let's test this one out. So there you go. That's how bad it is. It won't even move off of the first dot, which in capacitor world is a dead short, almost. So there you go. Won't even move off the first one. That's how bad that is. So just like the vacuum tube one over there, this is showing it as very, very bad. So there you have it. So by no means are these old bathtub style capacitors good to use anymore. And you'll see lots and lots of audio guys buying these things up and building single-ended Class A amplifiers with these things because they think that these things make their amplifiers sound better. No, no, no. These things are finished. They're done. They are past their due date. All right, do you think the radio receiver is going to come to life? So the only thing that's been done now is all the bathtub style capacitors have been replaced in those 3 resistors that we have tested. That's all that's been done at this point. So I've got my external speaker hooked up, and I also have an antenna hooked up to this thing, and it is in the broadcast band. So let's see if the speaker makes any noise. Oh, and by the way, this was a restoration video as well. If you look in my list of videos, you can see the entire restoration process of this speaker. We go out to the shop and you can listen to my noisy compressor and sandblaster as I sandblast the case and do all that kind of stuff. Anyways, it turned out very nice. This is a fantastic sounding speaker. So I'll turn this thing on, just walk over to the isolation transformer and current limited variac supply. Turn that on. So what do you think's going to happen? Place your bets. I don't see or smell any smoke. That's a good sign. So for those of you that are new to these older radio receivers, they've got vacuum tubes in them, and they take, about 13 to 20 seconds, something like that, to warm up. I think the standard warm-up time for a vacuum tube is between 11 and 13 seconds. For an indirectly heated tube, directly heated vacuum tubes heat up much, much faster. Somewhat like your microwave oven's tube. That's a directly heated tube. All right, so I will turn up the volume here. Life. I hear static. That's a good sign. Listen to that. Not doing bad. There are a lot of stations in there. This thing is receiving like crazy already. See if it, when we got up the band, I remember, let's listen. Peek up the antenna here. Oh, that's the tone. Doing this from the bottom side of the radio. And that's where it got quiet. Whoa. Oh, we had a station in there, and that's dead silent. So something's happening in here still that's making that happen. So let's find out what's going on here. I'll just grab the super probe, and this will give me a very quick idea of what's going on from the bottom side here. I think I have an idea of what's happening, but let's just see if it leads up to that. I'll go grab some tools here and we'll troubleshoot this. And I'll give you an idea of how to troubleshoot radios very, very quickly by doing this. All right, the radio is still on. I haven't touched anything. I just grabbed the super probe here. So let's attach this thing and let's see if the oscillator is running. Okay, so I'll just clip this anywhere. Now if the oscillator is running, I'll see that with this little light. This will detect the oscillator and this will start glowing. Okay, so I'll turn this on. I am not seeing anything here. Okay, so I'll move this around. So there it is, it started. Oh, it stopped again. So you can hear it. It's trying to pick up stations now. So the oscillator is stopping. So I'll turn this down, turn the audio of the radio receiver down. Okay, so let's see if the RF stages are actually working. This thing is so sensitive that it'll hear through the antenna in the RF stages. So let's see if the RF stages are still working even though the oscillator is stopping.
Into February, mid-Feb is when they'll be done with this. It's found at 190 seconds.
3 hours, and then that's it.
February.
So it is working. And you can see there's nothing in the oscillator, right? Nothing here. So that should stay on if the oscillator is running. Okay, so I'll go back down to the other end of the dial where the oscillator was running. I'll just turn this down. It was right down at the bottom is where it stayed running. There it is. See, now the oscillator is running and everything is quiet. See how bright that is? So the oscillator is running. Now I should still hear radio stations here.
Defense, wait. One. Sure.
So that's the second RF stage that we're listening to. We're listening to it through this speaker here. So this one here is completely unhooked right now. Or not unhooked, but just turned down. You can turn that one up as well. All right, so I'll just turn this right down. So now, so that's the second RF stage. Let's go to the first RF stage. Can hear it in there.
First degree murder. People killed in today's fire in North. Former city council.
So already we can tell that both of the RF stages are working, because we can see this is the first stage, so it's quieter here and louder here. So we know that the first stage is working, and we know that we're getting amplification because the signal that's here is louder in the second stage. First stage, second stage. First stage. So I'll see if I can find a strong station. Stronger station. So there we go. Hear that? Talking.
For a year now, central banks have been hiking interest rates in an attempt to raise.
That's with the oscillator running. So whether the oscillator is running or not, I'll still hear this. I can actually pull the oscillator tube right out and it'll still hear this. This is just detecting it right through the RF stage. All right, so I don't even need an oscillator with a super probe. It's so sensitive it hears stations without it. So now another way to tell if the actual radio receiver is working is I can go close to the detector tube. And it'll hear it down here as well. Just turn the volume down. So you can hear that. Hard to do this with not blocking it. So again, if I remove this out of here, you can see that goes off, and I'll hear the same thing with the through the speaker of the radio now. So it's the same thing, but it's just that the super probe is picking this up just by going through the different stages. So that's so strong, you can see it's detecting it quite nicely. And then of course, the oscillator is, you know, there's no modulation on the oscillator, it's just an oscillator. So that's why it just gets quiet. It's a nice clean oscillator, and that's why you can see that. So I'll just turn this up and you'll hear it get quiet. And that's how it's supposed to be. Now when the oscillator stops, of course the radio receiver is going to stop, because this is a heterodyne type radio receiver. And the reason that the oscillator is stopping when I'm rotating this, I'm having a feeling, I'm guessing that maybe the plates in the tuning capacitor are shorting out. So they're not shorting out in any of the RF stages or the antenna stage, because we still, you know, hear things over here, right? Whereas if I go here, right, I'll tune this to where the oscillator stops again. You'll see the light go out, the LED go out right here. Okay, so the oscillator stopped now, all right? But
digging into my box.
You can still hear that we're hearing signal. First stage, second stage.
Will capture your attention.
Of course, we're not going to have anything down here because the oscillator is stopped, right? We're not going to hear anything down here now because the receiver is quiet, right? There's nothing there. So this noise is usually shorting plates in the tuning capacitor. So let's test that. I'm going to flip this thing down and get all of this stuff out of the way, and we'll just take a look at that with a continuity meter, just a standard DMM, and see if the plates are shorting. That's how quick and easy it is to find problems with this thing. This is publicly released here on YouTube if you want to try and build this. So I released this. This is a public video. You can search through my videos lists for SuperProbe. If you're interested in the actual in-depth plans with circuit board layouts and everything like that, that is all up on Patreon as well. So you can take the files and just make yourself a SuperProbe. Many people have built this thing. This is a pretty popular device. You type in SuperProbe on the net, you'll find lots and lots of people have built these things. So this is another one of my little creations that I created a number of years ago. This is an absolute fantastic tool. Verified that the sections are working without connecting anything up, just by going close to the coils. It's just, I use this thing all the time. It's a great, great tool to have. It's good for looking for noise. If you have interference in your house and you want to find the source of noise, this thing is fantastic for that. All right, this is the tuning capacitor for the radio receiver, and this is the oscillator section right here. So let's see if the plates are shorting in this portion of the capacitor. So we want to see if the rotor portion is touching the stator plates over here. And we can do that with a simple continuity meter. All right, so what I'll do is I'll pull this off like so. All right, and I'll just put this here somewhere where you can see that somewhat easily. I can put this just down on the bench, so you'll see if I short the leads now, you'll see the meter respond. Okay. So what I want to do is go from the stator to the rotor. So right now this here would be the rotor portion, because the rotor is the case of the capacitor, and this here will be the stator. Trying to get this on here. Okay, there we go. All right, so this here is the case of the capacitor. So this here is these isolated plates right here. So you'll notice that. Right? So there we go. So now what I'm going to do is rotate the capacitor assembly, and we'll see if any of the plates short. So I'll just get on the other side of the radio here and start rotating this. What a surprise. Then we get down to the bottom portion of the band, it stops. So the rotor and stator are touching, which they can't do because they turn from a capacitor into a jumper at that point. So let's take a look a little closer at this and see what's actually going on. I'll just zoom on in. Hopefully that's going to get close enough. Oh, and we can already see that. Doesn't it look like these plates here are touching? Oh, just about. You can see a little bit of a shadow there. You can see through them just a little bit. But they are very close. They should be in the center or very close too. And now that I notice it, this screw here doesn't even look like it's screwed in, does it? See if that's screwed in. Look at that, that's loose. So I think somebody's been in here, and what they've done is they've maybe tried to play with the dial tracking. So these plates usually have cuts in them. This one here you can't do that with, because this is the oscillator section in here. It tunes so many different bands. So there are no cuts in the plates, but the rest of the capacitors here in the RF and the antenna section, you can actually, peak them up. So you'll see that there's little cuts in the plates here. See these cuts in the plates here? And that's so that you can move these. So see if you can see that little cut. There's a little cut right there. See that? See how I can move that? See how they're parting? So what you can do is you can make the actual the RF section track properly, so that as you're rotating the dial, everything is peaked up on the dial no matter where you go. And that's why they do this. And a lot of the times they have these in the oscillator section, but this oscillator section you can't do that with. And it looks like somebody may have been trying to make this thing track correctly by moving this over. But by doing that, they've caused the plates to short, and they've left a screw loose. So somebody was obviously sleeping. Makes me wonder how long this has been like this. Look at it, even looks like there's some solder back here. Look at this. Looks like there's like a chunk of solder or something on here. Look at that. Just picked that right off there. So somebody's fooled around with this. And you can see the plates are, you know, virtually touching. They should be in the center. So this is loose, and this is probably shifted over. So let's see if I can do this on camera. See if I can move this over. So the bottom side I would doubt has been tampered with because you can't get down to the bottom side. So we'll check that out here in just a moment. So what I'll do is I will see. Looks like they've loosened this up. Let's see if we can move this over. I don't know if this is going to be fastened in two areas. It probably is. So move this over. Let's see if I can move these. The whole assembly. Will it allow me to do that? I might have to move the block on the other side. It looks like just loosening that off fixed it, didn't it? It looks like it kind of popped over already. It does, doesn't it? I need a lens to get in just a little bit closer to that. Okay, so I'll tighten this back up. Is that what's doing it? Oh yeah, you can see them pulling over. See that as I tighten them up? See them pulling over this way? They're pulling over this way as I tighten that up. Right, well, these need to be tight. They can't be loose. There we go. That's straightening it out, isn't it? I think we're going to be good. So it was just this one screw. Somebody loosened this screw off. Let's make sure the rest of them are tight back here. And it looks like that pretty much straightened them. Yeah, see that? It's pretty much right in the center there. If you can see that. See that? It's not touching anymore. All right, I'll attach the speaker back up to this thing and let's see if the entire dial works now. That should be exciting. Looks like it's perfectly centered now. So somebody's actually loosened that screw off. That is a really odd thing because this is completely shielded. As you remember, we took the shield off. Like, who would actually take the capacitor shield off and adjust this? So definitely tampered with, or maybe even from the factory it wasn't tight and over the years it just backed out. Because it's really odd that the shielding on this doesn't really ever have to come off. The only reason that you would take it off is to maybe add a bit of lubricant in here and that's it. So, and usually the lubrication in these things, they just last and last and last. So that's a really, really strange thing to happen. I have never come across that where somebody has actually loosened off one of these and they've caused an issue. So very, very strange. So somebody's been probably tinkering around in here. All right, let's experience this together. So turn this on. Let that warm up. Regulator tube back there is glowing. All right. That's more like it.
Next morning he got it.
That's the kind of result that we're looking for. So that was the issue. That's what was stopping the oscillator. We're making great progress with this radio receiver. It's coming along quite nicely. I'm very excited about having this thing completely restored and aligned so that way we can listen to some signals from all over the world with this thing. I'm sure it's going to be incredibly sensitive. I'm very excited about that, and I hope you are too. If you want to be part of the Grand Receiver Restoration series, don't forget to subscribe and tap the bell symbol. That way you'll be notified as soon as I post a new video regarding this receiver or any of the other receivers coming up in this series. I've got lots of great videos coming here for Mr. Carlson's lab. Lots of great footage is coming. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, many of which you've seen here as I've been working on this radio receiver, you may want to check out my ongoing electronics course on Patreon. I share all my designs and inventions up there. There's a lot of great stuff there with over 150 videos at this time, and many projects for you to take part in, many things for you to build and follow along in. Lots of great stuff there as well. I'll put the link to that just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.